I'm gonna go ahead and get started in just I'm just gonna pin myself and then all right. So hi everyone, welcome to the final review. This is one of two reviews. I'll be doing another one on Sunday that'll have a lot more of the problems. This one's just kind of material and information. Just a quick reminder, your final exam is on April 25th from 3:30 to 5:30 p.m. in person in the building JFB in the room 101. So haven't been on campus. This is JFB. It is the physics building. And then on this map, you can kind of see, I'll go ahead and annotate it. This here is like the president's circle. So they've got parking all along this area here. That one U is paid hourly. And then there's also parking here. If you have a U pass, it's a really quick walk over. There's also a Northwest Garage because your guys is this after 3, so U pass will work there as well. Otherwise, you are able to park at the Union, but it is a bit more of a walk. And let me know if you have any questions. This is what the building looked like. This is the 100 South view. So 100 South is just right there. That's the view looking towards it. You'll want to enter through these bottom doors here shown where it's pointed. That's the closest way to room 101. It'll either be on the left or the right or further back on the left and the right. I haven't been there yet, but come early if you can, especially if you get lost. That building is a little bit confusing the first time you are there. And I'll be there too. I'll try to get there about 15 minutes early. Maybe I'll stand around, see if I recognize any of you guys, and help you to get in there. All right, don't forget that you have a cheat sheet. You're allowed to bring a 1-page handmade notes. Handmade means you write them yourself. You are able to have front and back, and you'll get credit for attaching it to your exam. For your cheat sheet, I recommend some general things, right? I think it's a good idea to have steps on how to do a type of problem. A lot of the key terms and definitions, you want to kind of go through all of your quizzes and see what key terms they've asked and kind of put them down just in case you forget. You can also, if you have a room, put bold for difficult problems. So if you have any difficult problems that you struggle on in the quizzes, go back and put those down, or like a similar example of how to do those. And then be sure to review your past quizzes and exams. Gradescope will have the rubric when you open it up. And then there are in the templates page the solutions for quizzes 1 through 13 and exam 1 and 2. Final information, so there is more of an emphasis. Everything after exam 1 is the majority of what your test will be. This is from the final exam information and practice page on Canvas. Pretty much everything that we've covered can be on the exam or is a higher version level of what you've seen already in the way of like the stuff before exam 1 probably won't be that simple, but it'll be like building on top of each other. Questions will be similar to the quizzes in difficulty and length. Our final is 7 pages long, so it's definitely longer than our exams, but you are given 2 hours and 10 minutes for our exam. If you go over time, there is a point penalty, and we'll just keep track of that whenever you turn in your exam. All right, so today, some quick expectations. I have some scratch paper ready. I don't think I have any big problems. This is more a lecture format where I'll kind of go over everything, and then on Sunday we'll have more problems to solve and figure out. But be sure to use that annotate button. Be sure to type in chat. I'll have it pulled up on my iPad so I can see what you guys are saying. And then, yeah, feel free to use the mic whenever you're prompted. And as mentioned earlier, today's focus will be mostly a review on exam 2, tying concepts together, kind of relating them. I'll try to mention like things that people often make mistakes on that I've seen, as well as keep your eye out for a little box that says put it on your cheat sheet, because I suspect that they will come up. Very beginning, we did linear functions and equations, your y equals mx plus b. Be sure you know what each of these mean. I think everyone's pretty good with this at this point. Be sure you know how to construct an equation using these y equals mx plus b's. Make sure you know your m and your b. And then quadratic equations, I think a few of us are still struggling on these. But remember, you have your three primary forms, your standard form, your vertex form, and your factored form. Make sure you know what each of the A, H, B, C, all of these different variables mean and how they kind of affect your quadratic equation. I recommend putting these on your cheat sheet, especially the vertexes. If there's looking at your past quizzes, I think there's a chance that you need to know how to graph things based off of these formulas. And if you know them quickly, then you'll have more time for other problems. Similarly, remember whenever we go from standard form to vertex form, we use the completing the square method. So we've started with our x squared plus 12x plus 32. That's our standard form. And then we go through all these steps to get it to the vertex form. The steps are listed here. I wrote these out, so maybe something like this would be useful on your cheat sheet, as long as this all makes sense to you. And if it doesn't, ask me, because I can help you with that as well. All right. And then just a quick reminder, this is the quadratic formula. I think most people really understand this one, so I'm not going to really go over it. Just remember that you take your standard form and put all your A, B's, and C's into this. If you are able to choose and you're confident using this one's pretty easy to use because you just plug and chug, whereas factoring, you kind of have to think a little bit more. Be sure to have this on your cheat sheet. Factoring, I think most people are decently comfortable with this. Just make sure that you remember your A, B, and your C on your standard form, and then your C is solved by factoring, and then your B is solved by adding or subtracting those factors in order to get your C. So whatever adds to B and multiplies to C. And remember, we can add negatives, so that's kind of the way I've said it. And remember, factor by grouping, where we can break up our middle term, or we're given a third x, like an x to the third power. We can't traditionally do it the same way that we do it for this one, as always. So you can do factor by grouping. This was, I think, like week 4 or 5 material, but just be sure you're comfortable with this. I have here a little worksheet that has good examples as well as the solutions posted. That one, I went through it and that's actually pretty useful. It'll get you going if you forgot how to do this. And then these slides will be posted after, so that link should work whenever you look at this later. The new stuff, remember we started square root since exam 2. I think most people that I've talked to and just seeing you guys in the discussion groups are pretty confident with square roots. Most people can understand that like you get 2 of the same and then you can take them out of the root to get like just alone. Don't forget your other square root rules where you have like a square root of 3 and you have a to the second. That's the same as a to the 2/3. That might be useful, especially if it asks you to simplify further. You can always simplify it to this kind of form. And this also helps you combine it if you have like an a up front. So then this would be like an a times a to the 2/3, which will go to a to the 5/3. Just something I would in mind that you can do. Similarly, logarithms are also new. Hopefully, the last quiz made sense to most people. I think most people got through it pretty easily. Be sure to write something similar to this where you have these two different forms that you'll commonly see, right? So you'll get this form and this form. And then this is nice because it's color coded. And you can do the same thing on your, I guess it's not perfectly color coded. This one should be green as well, right? But you should put something like this or whatever makes sense to you, like this, on your cheat sheet, because then it'll be really, this is really easy to confuse which one goes where, at least for me. So I recommend writing both of these and knowing how to convert back and forth between them. So like, for example, this one. This is similar to something we had on your quiz this week, where we are able to have this 5 to the log base 5 of 3. Because these have the same like base, right? And this is to the power, right? It's not multiplying, it's the exponent of. We can just say that this is equal to 3. And then similarly, where we start with a log base of 149, and then we want our little number is a base to an exponent, we're able to cancel these two bases out, and we're left with just 5. I don't think I wrote this, but just remember that you can do this. I know some people were struggling on, I think, question 2, the true or false. It is true, so you can have, I believe the question was like 5 log 5 of 125, and then it was asking you if it was equal to 125. The answer is true, so make sure you know that it's true. Right. Now that we've gone over that, we're just gonna try to turn this into an x equals form. So if anyone has the annotate working, or if you'd like to say in chat or using a microphone, please do so. And just as a hint, we're doing this here. How can I turn it into this first form here? I guess I should leave that up. Okay, we have 8 to the 10 is equal to x. And yep, great job. So yep, just be sure you know how to do this. And then if you get anything like this on the exam, they will not be this big of numbers. They might be something like 2 to the 3rd, 3 squared, anything like that. These are like easy to calculate without a calculator, right? Because it's just 2 times 2 times 2, 3 times 2, you know that's 8, you know that's 9. Those are easy enough. So you might be able to expect something like that, or even like maybe anything squared, because typically those are a little bit more common that you'll see. But if you get big numbers like this, just leave it like this. Don't try to multiply it out. You're free to just leave it like this. Because you know you'll get that big number in that. A little bit silly. All right. Moving on. Oh, same thing. So make sure that you have an example of this. This is a good example to put on your cheat sheet. It's really simple. The 10 and the 8 are very distinctly different. All right, so just a quick, let's go through these pretty quickly. So I've put numbers along each of these, and I want you to put in chat what number you think this function is. Is it linear, quadratic, exponential, logarithmic, an absolute value function, square root function? What do you think? You have a vote for linear? Okay. Yep, you guys are right. This is a linear function. What about this one? We have a logarithmic. No, we have a vote for exponential. Okay. We have some votes for exponential. All right. So you guys are right. This is an exponential function. And we can kind of keep in mind about this by seeing the 1, right? Because anything, or like your 0, 1 point right here. Because anything to the power of 0 is equal to 1. So like to the 0 is 1. 100 to the 0 is equal to 1. All of them are just equal to 1. So whenever you see this type of function, like you can categorize them by like the shape that like stays at 0 and then hits 1, right? All right. How about this one? Quadratic. All right. Yep. It is a quadratic function. It's your ax squared plus bx plus c. Great job. How about this one? All right, we got a vote for logarithmic, vote for exponential. Okay. It is a logarithmic function. And then I'll go over this a little bit. What about this one? Try to vote for absolute value. Okay, yeah, you guys are right. And that, or sorry, that you guys are right. Let me just fix that quickly. This is an absolute value function, and you know because there is a sharp corner at the v. Absolute values are always going to have a sharp corner, and then straight, like, and then the rest is linear. So, okay, there we go. And I just wanted to take a quick look at this. Remember how we have different ways that we can kind of change our function by having like different a's, k's, h's, b's, right? C's. In this case, we have it where, let's look at this green one here. So we've got a 2 up in front and a -3 here as well. So what does that kind of mean? So the 2, it does a vertical stretch. So then you can see it's like, instead of being normal, like the dark blue one here, this is our normal function. It's a little bit, it's stretched, right? So vertical stretch is like, it's like pulled this way. And then this -3 term is connected with the x, right? It's in the same type of parentheses or the same area as the x. And so then this means it's a left or right shift. So with left and right shifts, we kind of think of it as the opposite of what I would intuitively think of it. I know that a -3 means it's actually shifting 3 to the right. And we kind of covered this in exam review too. So if you'd like to, you can go re-watch that as well. Similarly, let's see, this red one here. Let's take a look at this red one. So we have the same thing. We have that same vertical stretch, and then we've got the moving 3 to the right. But then we also have this +4 term. And this +4 term isn't really connected to the x. It's like on the outside of the parentheses, outside of the absolute values, right? So that means we're moving it up or down. So in this case, because it's a +4, we just move it up. And that one's typically more intuitive. Yeah. Let's go ahead and move on. So remember, we had our exponential and we had our logarithmic. I explained a little bit of exponential, but remember that our logarithmic functions are the inverse of the exponential. And you guys already intuitively know this. You've got the two equations I showed you earlier. You're able to convert between them pretty easily. And you know that they're pretty much the same numbers, but just like a slightly different form. We rearranged it. We used log in one of them and we don't in the other. These are inverse of each other. So that just means that there is an axis of symmetry, right? And then I don't think axis of symmetry is a pretty self-explanatory word, but you can also put that in the cheat sheet if you would like. This line that I've drawn here is just y equals x. So in this case, our exponential is symmetric on the line of y equals x. So if you flip it, it's the exact same. And we can also see this with our 1, 0 and our 0, 1. That's a good way to kind of differentiate between the log or the exponential because they both have this like curved like shape, right? They both have the same shape, but they're flipped. So remember, it's around a axis of symmetry. All right. Similarly, we also have square root functions. And I think I talked about this a little bit in some different quiz group discussions, but you can see this blue one here is the square root of x. It's got that same kind of curved shape, but what's unique about the square root one is that it never goes below 0, at least in the typical sense, right? So it'll have a hard stopping point. Whereas with our logarithmic functions, it goes on forever at 0. So there's a x-bound axis. What is that called again? Sorry, it's slipping my brain. So make sure you get your vocab words. But the domain of like our log base 2 of x has a domain of 0 to infinity, right? Whereas our root has a range of 0 to infinity. So like our y values go on forever, but our x values start at x equals 0. So just keep that in mind. I'm not sure how much it'll be on the exam. I haven't seen your guys' exam, but this is just kind of a good summary to see how all the shapes are a little bit different from each other. And yeah, hopefully this is all review. Hopefully you guys have all seen this before. All right, moving on. This is really important and this will be really important forever. So make sure you know the definition of a function. The easiest way is when it's graphed. You have a vertical line test where you can move essentially a vertical line, and x equals a number, across the entirety of your function, and it'll never hit 2 points at once. So this left one here is a function, but this right one here is not because there's 2 points hitting it. Yeah, so just remember that every domain has exactly one range, or every f of x has exactly one x, or every x has exactly one y, right? So you just want to make sure that they're a one-to-one match. And if you need more help, this is hyperlinked. There is a link here. When I post them, it should upload the link as well, and you'll be able to click that if you are still confused. All right. So going on with f of x notation, all I've done is I've made, I guess, the same thing. Like I could have f of x instead of f of x here, I could have a y. And then instead of an f of x, this could be like an f of a, and this one here will be a. You can always change that variable on the inside, right? As long as it's the same input and output. All right, so here I have f of x of 2 of x. This is the red, right? Remember, this is an exponential function. We've got this y-intercept at 1. So then which one is f of x plus 1? What color do we think that is? Is it the blue or the green? And feel free to write that in the chat. All right, we got some votes for green. So it's actually the blue. And why is that? It's because the f of x is together with, or the one is directly parentheses with it, right? So what that would do is actually shift it 1 to the left. It's a little bit tricky. So then what does f of x of 1 look like? Do we know what the function would be? It's pretty obvious that's the green one. But what would that kind of look like? What would my 2 to the x become? So in this case, all I'm doing is I'm not doing what I did before. It's just 2 to the x plus 1. So that means I would just move it up 1, and I would get this green term here. So just keep in mind that when it's in the parentheses, every single x, every time you see an x, you want to replace that with whatever is in your new function. Okay. And I guess it is a little bit hard to see that it was shifted left, but you can kind of tell up here that the red goes into this blue here, just 1 over. All right, let's move on. So we have f of x is equal to x squared. Which one is 3x squared? Let's see, let me find, okay. Go ahead and give me a thumbs up if you think it's the blue one, and a thumbs down if you think it's the red one. The black one is our f of x, equals x squared. Are we doing a horizontal stretch or a horizontal shrink? Feel free to use the annotation if you want. Or not the annotation, the reactions. Okay, we get 1 vote for red. 1 vote for blue. All right. So here are our votes. So it is the red one. Whenever our A value is greater than 1, we perform this like vertical stretch or like horizontal like compression, right? You can think of it as being like pulled upwards, or you can think of it being compressed. I recommend just memorizing one way. I typically memorize the horizontal one. I'm like, okay, my 3 is big, so I'm gonna squish it. And then if it's like a 1/3, then I'm like, okay, I'm gonna stretch it by a factor of 3. I'm not sure if this will be on your exam, but I think it's pretty useful to know what different things do to your functions. I know there were a little bit on exam 1, so there is a high chance that this could be on your final. But like I said, I haven't seen it. All right, for more practice of what we just covered, This is the practice page 29 on the exam review PDF that is seen on any of the 3 exam pages. It's the exact same like exam review, like solutions and PDF. Page 29 does a really good job. It's kind of page 29 and 30. It asks you to kind of do both. So like A through C are tables, and then D through L are equations, and then the rest are graphs. I think it's a really good idea to take a look at this and see if you're able to recognize them just by like their function, or like just by their shape, right? We want to make sure we know them all 3 ways. Because you may, and then also on this one, be sure that you are comfortable graphing A, B, and C. You might be asked to make a table. I think you've been asked that before on a quiz or exam, so it wouldn't be too far-fetched to see it on your final. And yeah. All right, this one is just a review. So domain and range, remember which one is which, and if you keep getting them confused, write them on your cheat sheet. Remember your domain is the span of your x's, and your range is your span of your y values. And remember, you can always think of this as what direction are my infinity points going, right? Like I have 2 arrows that are going to go up forever. So that means I know it'll go up forever, but it won't go down past the point of 2. And because they're going up and out forever, I know that my x range is forever in both directions. That's the way I like to think about it. And if you need more help with domain range, just let me know. Be sure you know how to do it in this interval notation. This is, I think, what we've been using for most of the semester, because there is like x is all real numbers, which is one way that you could see it in the future. But typically they've been asking for interval notation, and I believe that was what exam 2 asked for as well. Make sure you know the difference between our rounded brackets and our closed brackets. These are up to and including. These are just up to and not including that number. Remember, infinity, we can't technically include infinity, so it's always an open bracket if you have an infinity sign. And that's just math notation. All right, solving inequalities, this is a little bit of the earlier stuff. I just wanted to make sure that you guys have this rule here, this 3rd one, where whenever we're multiplying or dividing by a negative number, we have to flip our inequality sign. And if that's a little bit confusing, take a look at, I believe, it's either quiz 1 or quiz 2, the very, very last question, where we had you add a negative sign to, I think, like a 7 and see if it was still true. And that's like a way that you can explain it, is when you have a negative sign, when you flip the negative, you also have to flip the inequality, because then 1 ends up on one side of the number line and the other, and it's not true anymore, right? Because when we flip this one's kind of hard to describe, but if you still have questions, just let me know. So here's an example of just a normal one. This doesn't really have the rule, but just remember how to solve inequalities and you should be all right. This is our exponent rules. We've had a lot of simplifying exponents, especially fractionals. So where we'll have like, I think we had it on both exam 1 and exam 2 and a bunch of different quizzes. So I believe it'll probably show up on your final. Have all these rules down, understand how to use them. Remember that your a and your n are different exponents. They can be replaced with a number or even a different letter. Make sure that you know product rule when you have the same base of a, like a 2 or 10, any of those same bases, right? We want to add them when we're multiplying. We'll add our exponents because we're multiplying the same base. Similarly with the quotient rule, this is both of these here, right? Whenever we're dividing oh, I guess not the second one, but whenever we're dividing, it's the top exponent minus the bottom exponent. You saw this with the last quiz where you did the log of, it was like log base of 2, and then it was like 2 to the 7th over 2 to the 10th. And then you could simplify that term into 2 to the negative 3rd, I think. And then you just got -3 as the answer. Remember how to do that? Because like I said, everything builds on each other. Similarly, remember whenever you have a fraction to an exponent, you distribute the exponent to both of them. This right here, I mentioned it earlier, you have anything to the 0th power, you'll always get 1. So that comes in really handy with your exponentials, where we had 2 to the x earlier and it always landed at 1. All right, negative exponents, we can always flip the negative sign to a positive sign, or vice versa by putting it on the top or the bottom of the denominator. But this is a really good table that kind of summarizes everything that you'll need. Remember that you might have 2 by 2 linear systems of equations. So think of when we had the requirement of we want to buy 10 fruits, but we only had a few dollars, and then an apple costed this much and a banana costed this much. So remember how to format those and how to create those functions, as well as how to solve for them. So there's 2 different cases, right, there's the easiest way to solve it is to do the substitution method. So you solve for one variable on the first equation and then just substitute that into the second equation. And then you're able to solve for the second variable. And then you can plug that second variable into your modified first equation. And then you'll get your x and your y, your apples and your bananas. Okay, remember that with these, there is a special case where you can get infinitely many solutions or you can get no solutions. I remember you get infinitely many solutions when you have the same slope on both of them. And then, or sorry, that's no solutions. When you get the same slope on both of them, you get parallel lines. They have the same slope. Infinitely many is that they have the same, is that they have a constant that you can't plug back into B, because then you'll get the same one. You can look at quiz 5 for an example of this. This is just a quick review. This one, when you simplify this, so say I divided this second one, every term by 2. So I'm going to divide that by 2, divide that by 2. Oh, it's not this one. Sorry, this one, we do get 2x plus 3y is equal to 4. This is slightly different than the one I thought I put on here. But what, oh, I guess I gave it away. All right, so remember that these lines will never intersect because they have different like b values. We can bring this into like a y equals mx plus b form, where we'll get like a 3y is equal to 2x, and then one will be a -5, and then one will be a -4. So because these two are parallel, they'll never intersect, and you'll have no solutions at all. I recommend writing both of these, knowing that both of these can happen. So that way, in case they pop up, you don't get confused. And if you have the space, be sure to write how to do the substitution method. You can write steps, even an example. The 10 fruits example was a pretty good one. I think that was quiz 5 as well. Make sure you know how to model them. And then similarly, you'll have 3 other types of functions that you might be asked to model. So with these, there's typically some pretty like normal story problems that you'll see. So with a parabolic function, we throw up a ball in the air and we see what time it lands or the maximum height that it reaches. And I covered this a lot more in exam review 2, but we can kind of know that if it's a curved shape, it'll probably be a parabolic function. So throwing a ball up and down. And we'll also have exponential functions. So think about growing your money in a compound interest account. And I'll go over these a little bit more, but then we also have logarithmic functions where you can think of your bacteria growing at a doubling rate, as we saw in quiz 13. So this is an example I've used before, but a baseball player throws a baseball in the air with initial velocity of 30 meters per second. The height of the baseball above the ground is given by this function. T represents the time in seconds after the baseball is thrown. How many seconds does it take for the baseball to reach the ground? So we have a t squared term. So we know, and we were given this. So this is, we know, will be a parabolic, right? A quadratic equation. In this case, I'm doing this motion. It's an upside down parabola because our a term is negative. We've got a -5. So is that going to be, so if like this is my -x squared, is my -5x squared going to be squished or is it going to be stretched horizontally? What do you guys think? So remember our stretch or squish factor depends on whether this number right here, regardless of the negative. So the negative and positive tell us which way our parabola is facing. So this is, sorry, this is -t squared. T squared would look like this, right? So the negative tells us if it's a U or an upside down U. But the 5 or 1/5, if it was like it's like a 5 or a 1/5, it would tell us if it was stretched or compressed. In this case, we've got something like that. Anyways, going back to this, remember that this is our A term. That kind of tells us how the normal parabola is either upside down or normal, and then stretched or not. All right, so then how do I find how many seconds it takes for the ball to return to the ground? Do you remember how to do this? So we want to know when h of t is equal to 0. So then we set our whole thing equal to 0, and we solve for t. So as you can see here, I've already done that. So I set it equal to 0 on, let's do on this step here. And then I factored it in order to solve for t. So remember, everything comes together and you'll be using different tools to be able to apply to different scenarios. So solving for t is what I did in step 2, and I got t is equal to 4 seconds. Okay. Hopefully this is familiar. There are a few review problems on this in the PDF, so be sure to look out for those if this is not familiar, or if you want more practice with it. So given the same equation, we can also try to find the maximum height. I remember this is where that vertex comes in. This is where we want to use our knowledge of parabolas to be able to just know the kind of thing that we're solving for. So we know at every vertex and every line of symmetry, that same, or axis of symmetry, right? Same on both sides, our vertex is at the top of that. We're gonna solve for a vertex. So remember, we know that the vertex is either the maximum or minimum. When our A value is negative, then we know it's the maximum because we have this upside down parabola. This is a negative 2t, right? We know it'll be a maximum value. So that makes sense. Then remember, you have to solve it by putting in, well, you don't, but you can solve it by putting it into vertex form. Remember our HK form. So this is the same slide I covered in exam review 2. If you're still confused on this and want more help on this, be sure to watch the video. It is linked. That's another person that it's just a YouTube video I found that it might be useful, especially if you need more help on this. And then remember, we also have our exponential function. So this is from one of the quizzes, pretty similar. Suppose you invest $1,000 into a mutual fund that offers an interest rate of 5% compound each year. Let M of t represent the amount of money in the mutual fund after t years of initial investment. Write an algebraic rule for M of t. And remember exponential. So when I think of exponential, I'm like, okay, how do I write this? Anyone remember this? And if you're able to annotate, feel free to let me know, or write or type whatever you'd like onto the screen as well. Or put it in the chat and I can write it out as well. And remember, compound interest is where we start with our dollar, and then in the first year, it increases by 5%. And then in the next year, we take that 1,000 plus that 5% money, and then we compound it another 5%. So we want to model a function that's able to keep adding on to that. All right, so we've got 1,000 times 1 plus 0.5 to the t power. And yep, that is exactly what we want. We have 1 plus 0.05 to the t. And remember, this term here is the same as 5% because all we've done is we've moved the decimal place by 2, and then that makes it a percentage. And then, yeah, we want to make sure we bring it to the exponent of t, so that way we can describe the amount of years. And we are multiplying here. We're not adding because we have this t term that allows us to multiply it throughout multiple years. All right, yep, and there it is written. And this one is pretty recent. This is from quiz 13. But this is more of a logarithmic function. So a biologist is studying the growth of population of bacteria in a lab. Population doubles every hour. If the initial population is 100 bacteria, approximately how many hours does it take to have 1,000 bacteria? And then this one, it cues you to use a logarithmic function. So then what would we get here? Actually, I think I wrote it for, okay. Let's have it triple every hour. I changed the second slide, right? And changed the first slide. So what would this one look like? Let's make this P of T. So population of bacteria. And then T is our hours. Yep, as always, feel free to write it in the chat or be sure to annotate it. So we want to start with 100 bacteria. So let's model the population first, and then we'll solve for bacteria later. So we have an initial population of 1,000, and we know it triples every hour. So we want to multiply it by a factor of 3 for the first hour. I think we know it'll multiply by 3. But then what about the second hour? We'll do it by 3 squared, right? Because we'll have 100 times 3 for the first hour, and then we need to, and then after another hour, it gets multiplied by another 3. And then another hour, it's multiplied by another 3. So then it becomes something like that. Except our 2, in this case, will become our time. And hopefully this explanation kind of helps tie things together, where we have like every single hour, it gets multiplied by another term. And then if it's every single hour, then, oh, we can just make that an exponential. All right, and then let's go ahead and solve for it. So now that we have our function, we want the population to equal 1,000. Remember, we're putting that in the P of t side because this represents the population in terms of time, and then this also represents a population in terms of time, but it has our t used as a variable. So then we'll do 100 times 3t, and I'll divide both sides by 100, and then I'll get 10 is equal to 3t. And then this is where we want to use our log functions. So remember those two equations? How do I convert this so I'm solving for t? What does t equal? Log, what's my base? Yep, I have a log base of 3, and then we have 10. All right, and remember, we always put our bases here, and then our bases are here. So that's another way to think of it. As long as you know it's like log base number is equal to our exponent. That's the way that I like to think about it whenever I think of logs. So log, my base, my number I'm trying to solve for is equal to my exponent, and then my base to that exponent is equal to the number of. I like to write it out in words, but if the equations I showed earlier work for you, then that works as well. That's all I have for you guys. The session on Sunday will be a lot more of problems, going over problems, and solving problems. This has been recorded, and yep, thank you for coming. I'm going to stop the recording now.